So today we are going to learn about end behaviors of polynomial. End behavior means what happens to the graph as it gets very large. Large means at positive infinity or very small negative infinity. Like if I have a graph, right side this is positive infinity if I keep going in this direction, and left side is negative infinity. So basically, we are going to learn how does the graph behave at the far left and at far right. Is the graph going to go upward, downward, or uh, so? Basically, the end behavior depends on two things: the degree of polynomial. Degree means highest power. Like if I have x to the power 4 plus x square plus 6. So the degree of this polynomial is 4. And the leading coefficient. Leading coefficient means the number in the front of highest power. So highest power is 4 and the coefficient of x to the power 4 is 1, right? So leading coefficient is 1. Um, so let's start. Let's take few example to understand the end behavior of polynomial. Let's say I have this polynomial y is equals to x square. So I know because it's a quadratic equation, so it's going to be parabola and there is no term other than x square, so parabola is going to pass through origin. This is how y is equals to x square graph looks like. Both side it goes in the upward direction, right? Right side, right is this positive infinity and left side which is negative infinity. So as x goes to positive infinity, uh, I'm talking about right side, I will write right side. So as x goes to positive infinity, my graph is going in the upward direction, right? As you can see in the upward direction. So I can write fx goes to positive infinity. Upward means positive. And if you check left side, so for left side, as x goes to negative infinity, left means negative infinity, the polynomial graph is also again it is going upward in upward direction. So I can write fx goes to positive infinity. So this is the end behavior when my as you can see degree is 2, so degree is even, and leading coefficient, the coefficient of highest power uh, term, this is 1, positive 1. So your leading coefficient is positive and degree is even, right? So this is the end behavior when degree is even and leading coefficient is positive. Let's see if I take same example, but this time my leading coefficient is negative. Um, so the graph is again parabola because it's a quadratic equation passing through origin because there is no term other than x square, but now it will go downward because leading coefficient is negative. And now again I can write my end behavior for this polynomial. So as I go right side means positive towards positive infinity, so my x goes to positive infinity. As x goes to positive infinity, fx goes to, because it is going downward, so negative infinity. Now if you check at the left side end behavior, left means negative infinity. So as x goes to negative infinity, fx again going downward, fx goes to negative infinity. For downward we write negative infinity, for upward direction we write positive infinity, right? So this is the end behavior when power, because this is my polynomial, so degree is even but leading coefficient is negative. Now let's take um, example of any polynomial which has odd degree. So let's say y is equals to x cube. Now my degree is odd, right? Degree is 3 for this polynomial. Leading coefficient is positive, positive 1 in this case. So for x cube, the graph looks like this. S shaped, um, something like this. So if you check right side, this, as x goes to positive infinity, fx is, my function is going upward, right? So fx is also going in positive direction. But if you check left side, this negative infinity, this, so for left side, as x goes to negative infinity, my function graph is going downward. So this is downward means negative infinity. So this is the end behavior when leading coefficient is positive and degree is odd. Now let's make leading coefficient negative. Let's say my function is y is equals to, or fx is equals to, let me write fx because I'm using fx is equals to negative x cube. So now the graph looks like this. Uh, oops. It looks like something like this. So if you check positive side, I mean right side, as x goes to positive infinity, I'm talking about right side, fx is going downward, right? This side fx is going downward. So fx goes to negative infinity, right? This is for right side. For left side, this side, for left side, as x goes to negative infinity, my function is going upward, as you can see here. So upward means positive infinity. So this is the end behavior when degree is odd but my leading coefficient is negative, because it is -1. That's how the polynomial behave at extreme ends. So um, basically what we have seen is when degree is even or when degree is odd, or if the leading coefficient is positive and leading coefficient is negative. So when degree is even and leading coefficient is positive, what I have observed is that graph goes in on both side, right side and left side, it goes in the upward direction like this, right? But when degree is even but leading coefficient is negative, then it goes downward. So both side, left and right side, the graph is going downward. When degree is odd and leading coefficient is positive, the graph looks like this, something like this, passing through origin actually. So it goes downward, left side, and right side upward, right? And when degree is odd, leading coefficient is negative, it's opposite, like this. That's how you can remember end behavior of polynomial, right? um, so that's it for today. Thank you.